Today we're going to learn about graphing quadratic equations. So we're going to start off with our parent function, and we have a little table here that gets us our original points. So it's f of x equals x squared. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared, 2 squared. Now when you do negative 2 squared, be careful, because if I put in negative 2 squared, I get negative 4. And we know a negative times a negative is a positive. So that's happening because the 2 is getting squared, but not the negative 2. So if I want to square negative 2, I need to put it in parentheses. And then it will multiply negative 2 times negative 2 and give me the correct answer. So be careful. Your calculator does what you tell it, not what you want it to do. So we graph these points. Negative 2 goes up to 4. Negative 1, 1, 0, 0, 1, 1, and 2, 4. If we did 3, it would go up to 9. So we know this is a parabola, so it's a U shape, not a V, not like our absolute value. The domain of this function is all real numbers. I can put anything in for x, but the range is only positive numbers, greater than or equal to 0. So equal to 0 to infinity. My domain and range. All right, next, let's just review the transformations real quick. They have not changed. The a value still tells us if it's a reflection over the x-axis. If there's a negative number in front, that's a roxa. Remember, if absolute value of a is greater than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. A vertical stretch is going to make it skinnier. A vertical compression is going to make it go wider. The h value is the one that tells us how far it goes left to right. Remember, a negative h goes to the right, and a positive h goes to the left. And then our k value tells us how far it moves up and down. A plus means up, a negative means down. Now, the h and k significance here is, we ask you, what is the vertex of your parabola? You're going to say that it's hk. So the h, the opposite of what's here, and then k, the same sign. That's your vertex, and everything moves off of that. So this one says list the transformations, and then we'll draw a graph. So first off, I notice it's a vertical compression of 1/2, and that it goes to the left 3 and up 4. So that means my vertex is at negative 3, 4. And I can graph that right here. Now the 1/2 is going to make it a vertical compression. So it's going to look a little bit wider than our parent function. So we can grab our calculator and go to y equals, and we'll just type this equation in. Get our fraction, 1/2, parentheses, x plus 3, close the parentheses, squared, plus 4. And if you want to look at it, you can. There it is. So we're going to pull some points off the table, second graph. And remember, don't worry about the fractions, just pull the whole numbers. And we're going to find points that are actually on our graph. There it is, negative 1, 6. And then negative 3, 4, we've got that one. Negative 5, 6. And I think that's all that's going to fit on our graph, because negative 7, 12, this only goes up to 10. So we know it's a U shape. Try to make it look like it's round and not pointed, but there we go. The domain of this function is all real numbers. Your domain is always going to be all real numbers. No amount of transformations can change that. But since it did move up 4, my range goes from 4 to infinity. And 4 is included because it's on the line. All right, let's do another one. This one says negative 3. X minus 4 squared minus 5. So that negative is the reflection over the x-axis. So this one's going to be concave down. The 3 is a vertical stretch by 3. Remember, when you take the vertical stretch, the negative has already been dealt with, so it's just the 3. That 4 means right 4 and then down 5. So I know that my vertex of this graph is at 4, -5, right here. And I do know that it's going down because it was a roxa. So let's plug this into the calculator and we'll pull some points off of our table. -3 x minus 4 squared minus 5. And I put an extra parentheses in there that didn't belong. There we go. All right. So you can see it's down. It does look pretty skinny compared to the other one. Let's see if we can get any points off of this. Whoa. Okay, let's find something. Oh, there's -3, 8. And I bet 5, -8 is also going to be on there. I said -3, that was +3. Yeah, and the next point's -17, which is off my graph. So I'm just going to connect the ones I've got, make it a U shape, and there you go. All right, next page. Write an equation for the quadratic function that's been translated up 3 and to the right 7. So I know I'm starting with y equals x squared. Up 3 is going to be my k, and right 7 is going to be my h. We used to call those d and c in our old formula. Y equals, to the right 7 is -7 squared up 3. There we go. Next, we're going to write an equation for the quadratic function. So it's y equals x squared again. Everything in this unit is left 4, down 6, vertical stretch by 7, and a reflection. So the reflection is going to be negative. The vertical stretch is 7. Left 4 is x plus 4, and down 6. And there you have your equation. Now we've got a couple of review questions just to refresh your memory. For this quadratic equation, identify the axis of symmetry, vertex, and maximum or minimum. Well, the axis of symmetry formula is x equals -b/2a. So in this equation, b is 8. So I'm going to write -8, and a is -2. There's my a, my b, my c. So a is -2. So that means I've got -8 over -4, which is +2. So my axis of symmetry is x equals 2. So my vertex, I know the x coordinate of my vertex is 2. And I just need to find out the y coordinate of my vertex. So I'm going to plug my 2 into this equation and see what the y coordinate is. Let's see, 2 squared is 4. 4 times -2 is -8. Plus 16 is 8. I'm going with 9. But that was me doing it in my head. Let's double check and make sure I did that correctly. Because if you don't want to do the mental math, you have a calculator. -2 times 2 squared plus 8 times 2. Whoops. Plus 1. Did I type that correctly? I did. Equals 9. All right, the y coordinate of my vertex is 9. Axis of symmetry, vertex. Now, is this graph going to be a maximum or a minimum? Well, I know because of the negative that it's a reflection, so that means the vertex is going to be a maximum. All right, 2 more on the review category, rewrite in standard form. We're just going to practice multiplying everything out to put this back into standard form. Remember, standard form is the one that looks like this. So here we go. I am going to multiply my binomials first and then distribute the -2. It doesn't matter what order you do them in, but that's what I'm going to choose. So I've got 4x squared minus 3x minus 28x plus 21. So that means 4x squared minus 31x plus 21. Now I'll distribute my -2, and we will have our standard form. -8x squared plus 62x plus, oops, that's not a plus. -2 times 21 is -42. And that is the standard form of that equation. All right, same thing, but this time I've got to square my binomial. So that means I'm going to write it twice, and then we'll multiply it just like we did the previous question. So here goes. 2x times 2x is 4x squared. 2x times 1, 2x times 1, 1 times 1. And don't forget there's -7 in the back. We'll have to subtract that later. So I've got -3, and then 4x squared plus 4x plus 1 minus 7. So I'm going to distribute my -3 into the parentheses, and then we'll subtract 7. So I've got -12x squared minus 12x minus 3 minus 7. Here we go. Final answer. -12x squared minus 12x, and -3 minus 7 is -10. That is the standard form of this equation. Now it's time for you to practice your transformations.